decathlon, worksheet number 19, synthesis. This is a good one. This starts out pretty cool. So we have this radius inside of a circle, and we have a tangent, and we need to know, remember we talked about this earlier, every tangent to a circle is always going to be perpendicular to the radius coming off of it. So that's really, really cool. That's a really, really neat thing. That is a cool thing. So if we extended this line, it would contain both of these points. And we could calculate the slope. So we can make this 0.1 and we can make this 0.2. And so this is going to be x sub 1, y sub 1. This is going to be x sub 2, y sub 2. And we can use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is 0 minus y sub 1. X sub 2 is negative 3 minus x sub 1. And we get negative 5 over negative 5, which means a slope of 1. Now, we know that all perpendicular lines have a slope that is the opposite reciprocal. So for instance, if the slope was 3/4, the perpendicular slope would be the reciprocal and the negative of it. So it would be negative 4/3. If we have the slope of 2, it's going to be negative 1/2. If we have a slope of 3.5, oh, that's the tricky one. 3.5 is 3 1/2, which is 7/2, so it'd be negative 2/7. If you have a slope of negative 5/8, the slope perpendicular to that is going to be positive 8/5. We're cool with that? Good. So the slope, the inverse reciprocal, is going to be this line has a slope of negative 1. So we have the slope and we have a point that is on there. This 0.25 is also on that line. So when we y equals mx plus b, so we have the slope. Slope is negative 1. We have a point, which is 2,5, I think it was, 2,5. So we can plug those things in. Y is 5, m is negative 1, x is 2, and b we're looking for. So we get 5 equals negative 2 plus b. We're going to add 2. And we get 7 equals b, and now we can write in slope-intercept form the equation for the line containing that point. Find the equation of the tangent line in the diagram. That line would be y equals negative x plus 7. Find the equation. So that's in slope-intercept form. You could have used point-slope, sorry. This is in slope-intercept form. It didn't say which form it needed to be in. That could be one of them. If we wanted point-slope is y minus y sub 1 equals m times the quantity x minus x sub 1. So we can plug those values in. Y sub 1 was 5 equals the slope is negative x minus 2. So that is in point slope form. Point slope form. Or if you wanted to put it in standard form, I would use my slope intercept form. We can go y equals negative x plus 7, and we could add the x over, and we get x plus y equals 7 is in standard form. And remember, when it's in standard form, a, b, and c must be integers, whole numbers in their opposites, and a must be positive. So in each of those, a is 1, B is 1, C is 7, so they're all integers, and A is positive. That's a good starting problem. Let's go! Write an expression for the volume of the shape below in standard form. Volume equals big B times H. The base shape is a rectangle, so we have length times width times height. Let's do this. The length, let's highlight what the length is. This is going to be the length. This is going to be the width. And this is going to be the height. So we're going to take those values and we're going to plug them in. Volume equals length is 3x plus 1 times the quantity, let's put braces, times 2x, which is the width, and then we have to multiply it by the height, which is x plus 2. So let's look at that. So if we distribute that in, that's going to be 6x squared plus 2x. And all I did was distribute 2x times 3x is 6x squared. 2x times 1 is 2x. And now we're going to multiply this by x plus 2. We're going to have to double distribute, or what we call FOIL, first, outer, inner, last. So I will do that relatively fast. You have 6x squared times x, which is 6x cubed. 6x squared times 2 is 12x squared. 2x times x is 2x squared. 2x times 2 is 4x. We have like terms here. So 6x cubed plus 14x squared plus 4x would be the expression. I think it even said in standard form. Yes, that would be standard form. Cool? Cool. The square of an irrational number is the square of an irrational number. Well, an irrational number is the square root of 3. And if we square that, is always rational. Irrational. Yeah, but that works. So that's a yes. However, if we square pi, pi is irrational. That does not equal a rational. Rational? No. Still going to be repeating. No. So that's a negatory. So that's going to be sometimes. So the answer would be sometimes rational. The sum of two positive irrational numbers is always irrational. An irrational plus an irrational, is never rational. Is never. Repeating plus a repeating is never rational. Yeah, sorry. It's never rational. It's always irrational. The difference of two irrational numbers is sometimes. I think that's sometimes also. Yeah. I'm going to say that's sometimes rational because they will cancel each other out. You know what I mean? If you have, let's do the square root of 3. Square root of 3 is irrational, and I minus, 2 rad 3, that's going to give us a rational number. All right, let's do that. Let's do 2 times square root of 3 gives us that number. And if I minus 3 square root, it should give it. I messed it up, sorry. So if I do 2 times 3 square root equals, that's going to be 3.46. And if I subtract 3 square root, we got the square root of 3. Well, it is sometimes. What's the example I want to give? Difference of two irrational numbers is sometimes rational. Yeah. Like rad 6 minus rad 3 is not going to be, rational, right? So I can give a situation where I have rad 6 minus rad 3 equals an irrational number. However, if I have 2 rad 3 minus rad 3, that's going to equal 2, and that's rational. No, that doesn't equal that. That equals rad 3, which is irrational. Oh, no, yeah, irrational. That's irrational. So that didn't work. Two irrational numbers. Oh, yeah. How can I make it sometimes? I know it's in my heart of hearts, I know it's going to be sometimes. And that's dividing. I'd have to look, so you'll have to figure that one out. Sorry, I'm going to have to come back to that. If x is a positive integer, which will be greater, the mean or the median? If x is a positive integer, which will be greater, the mean or the median? Which will be greater, the mean or the median? Well, we have x plus 1, x plus 2, x plus 3, x plus 5, x plus 5, x plus 6, x plus 6, x plus 7, x plus 7. Let's group that. Group. We have x plus 7, x plus 7, and x plus 8. So, the median, the middle, is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 and 6, 1, 2, 3, 5 and 6 is going to be this. So that's going to be x plus 5.5 would be the median. And the mean, if we added all those up, we have 3, 6, 11, 16, 22, 28, 35, 42, 50, and we have 10x plus 50 divided by 10, which gives us, we can factor out a 10, you get x plus 5 divided by 10. And so your mean is going to be x plus 5. So x plus 5, and this is x plus 5.5. So the median is going to be the bigger, is going to be the greater. Oh, I like that. That's a good question. That's kind of cool. I wish I could think of an example why it's the difference, the subtraction of two irrational numbers. What is that one positive answer? What is that one successful? I can show where it's not. So let's look up on the internet. What two irrational numbers subtracted is rational? What is that example to get a rational? Can you subtract two irrationals be rational? Whew. Oh, okay. That's good. That's an easy one. When subtracted from 5 rad 3, we get... Oh, well, that's the easiest. That's the easiest one. No, that's example of that, no. I kind of want more than one of those. Cora. Well, that looks like it's going to be the one time when it is. So our example would be rad 2 minus rad 2 equals 0, which is rational. Okay, that's why it's sometimes. That one was tricky, but I knew in my heart of hearts. Good luck with that one.